types of problems, do you want us to physically write out LA to Dallas for Dallas to GB3 and then multiply it, or can we just do 4 times 3?
No, you can just do 4 times 3. I'm just doing that for that way you know what well, how did we get the 4? The 4 is because we're doing LA to Dallas, and we get the 3 because we're doing Dallas to Green Bay. But you can
Okay.
just put 4 times 3, and that should be good. All right. So let's do this next one. So for this one, say counting without repetition. So that means once you select it, you can select it again. So for this one says, if we have 4 people waiting in line to pay at Sprout, in how many ways can we arrange Archer, Ben, John, and Rick in a queue? So you kind of imagine we have 4 people waiting in line. So they're all waiting in line to pay. So we're just trying to see like how many different ways can we arrange the people in a queue. So we're gonna put, this is the first person to pay. This is the second person to pay, the third person to pay, and then lastly, the 4th person to pay. So how many options do I have to put for the first one, the first person to pay?
4.
Yeah, 4. So we have Archer, Ben, John, and Rick. So we have 4 people to select. So say the first person we pick and is Archer. Cool. So is it possible that Archer could be paying the first, but also be the second to pay?
No.
No. So once you select Archer, pretty much you can't select Archer again. So now, how many people do I have to put for the second selection or the second person to pay?
Yeah, 3.
You got 3. What about for the third person to pay?
2.
2. And lastly, the 4th person to pay?
4.
1. So you multiply these out, and you get 24.
Ahorita, dame 5 minutos, les jabón, ahorita te lo traigo.
All right. And that's how you do that last problem. Any question for that last problem?
Nice.
All right, sweet. So let's do the next one. I think then we're gonna get into permutation. There you go. All right, so for this one says, calculate how many 5-digit password for a cell phone can be formed from 0 to 9 where no digit can be repeated. All right. So for this one, how many digits should this password have?
5.
5.
Yeah, so it should have 5. So we have the first digit, we're gonna have the second digit, we're gonna have the third digit, and we're gonna have the 4th digit, all the way to the 5th digit. All right, everybody go with that so far?
Yes.
All right, so from 0 to 9, how many number can we choose from?
10.
Cool, perfect. So you have 10 options from 0 to 9. Because for this one, you also have to include the 0, so that will make it 10. Okay, so this is the first digit. So when I'm choosing the first digit, how many number can I choose from?
10.
So it's 10. So we have 10 options. What about when I'm choosing the second number? How many number do I have to choose from?
9.
Cool, 9. The reason why you get 9, because if you look right here, it says no digit can be repeated. So once you select a number right here, you can't select that number for the second position. What about for the third position? How many numbers do I have to choose from?
8.
8. What about for the 4th one?
7.
And 6.
Cool. Any question? I got 10, 9, 8, 7, 6.
No.
All right, so we're gonna go ahead and just multiply these out.
Yeah.
3,240.
Yeah.
No, that's
I'm
right.
going to save that one.
No, yo lo voy a comer.
10 times 9 times 8 times 7 times 6. and you get 30,240.
In the little small
All right. And that's it for that one. Any question for that last part? All right. So let's go on down. All right. So for this one, we're going
Wait, the last question was, what's the probability that a random person can guess the correct password for a cell phone? That's just the results.
Oh yeah, sorry. Cool. So yeah, so this is the result. So that's telling us how many different password is possible. So if you want to find the probability, how many correct password is it to a cell phone?
1.
Yeah, one.
Would you just put all the numbers over 1 and then multiply them?
Well, yeah, or you could do 1 divided by 30,240,
Oh, that too.
and that should give us a very small probability of occurring. So for that one, you should get 0.00003. So it's a very small probability that somebody can randomly guess your password. All right. Well, thank you for that. All right. Any other question in regards to this one?
Well, this is not my. I'm pretty sure someone. I don't know if you've answered this question before, but the e to the negative fifth means that you're gonna go 5 zeros to the right, right?
It's the opposite. So you see how I had 3.30687?
Mhm.
So the e to the negative 5, it corresponds that I get this decimal and move it to the left, not to the right.
Because it's negative.
Because it's negative, correct.
In that case, it's kind of like scientific notation.
Well, it is scientific notation. The thing is that E is corresponding to times 10 to the negative 5. But instead of putting times 10 to the negative 5, they put the E, which the E represents that.
Oh.
So then you put 0, 0, 0, 0, and that's how I got the 0.0003. But yeah, the E represents the times 10 to the negative 5.
For sure.
Cool. Yeah, good question. Any other question? Perfect. All right, sweet. So let's get on to permutation. All right, so before we get on to permutation, you kind of have to know about something called a factorial. A factorial is this exclamation mark. So that exclamation mark, whenever you see a factorial with a number, it just means that you get that number and you keep on multiplying by a number smaller than that number until you finally get to 1. So let's do a simple one. So let's say 4 factorial. 4 factorial will represent that you get 4. And you multiply by a number smaller than 4, which is 3. And all of these numbers are always whole number. And then you multiply by 2. Then you multiply by 1. So if you do 4 times 3 times 2 times 1, you're going to get 24. So that would an exclamation mark represent for this formula. If you ever see an exclamation mark, it's telling you get that number, and you keep on multiplying by that a number smaller than that number until you finally get to 1. There's also a special case scenario. If you have 0 factorial, this is yes equal to 1. So if you get 0 factorial, it doesn't make it equal to 0. It actually is equal to 1. All right. Everybody get kind of what a factorial is?
Yeah.
Cool. All right. So we're going to work on permutation. So for a permutation, 3 things has to happen for it to be a permutation. The first thing, n objects are distinct.
Su cabeza.
Doesn't it look cute?
Right. So when it says n objects are distinct, it just means from what I'm selecting, each one of them had to be a different number or a different object or a different person. It is saying there can be an object that could pretty much be identical to other object there. All of the objects have to be completely different from another thing. So kind of look at the problem that we just did about the different digits. Each digit has to be a different number, and each number was different. So that what an object or distinct represent is saying how many options do we have, and each option has to be different from the other options. All right. Any question in regard to an object or distinct? All right. So the second one is a repetition of object is not allowed. So that just means once I select that object or that person, I can't reselect that person again. So once you select them, pretty much you select that person or that object, but you can't reselect it for the second time or the third time you're picking. All right. And the last thing is order is important. So the way that I select the object or the way I select the person does make a difference. So for this one, it is saying like if I arrange A, B, C, and you do C, B, A, they would count it as two different results because the way that we arrange the letter does make a difference. So order is important. So if those three things check out, we're going to say it's a permutation, and we're going to be using this formula over here for that. All right. Everybody good so far on a permutation? All right. So first thing we're going to do a very basic problem. So for this one, I already told you n. N is 7, R is 4. So n represents how many total options we have to choose for. R represent how many of those options are we selecting. So I'm going to go ahead and just use this formula. So for this one, it says you get 7 factorial divided by n, which is 7, minus r, which is 4, and that'll be factorial. All right. Any questions so far? I got 7 factorial divided by 7 minus 4 factorial. Cool. All right. So then we get 7 factorial. And if you look at this, 7 minus 4, that'll give me 3 factorial. So then what I could go ahead and do, I could do 7 factorial. So 7 factorial represents you get 7 multiplied by 6, multiplied by 5, multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. And you divide this by 3 times 2 times 1. Yeah. So n represent how many different options or how many different people you have to select from. R represent how many of those options are you going to select. So n is equal to 7 means there's 7 total options to select. R represent how many of those 7 we're going to select. So it's telling us we have 7 options and we're going to select 4 of those options. Any questions so far? I got 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1.
Can you like cancel out 3 and 2 and 1?
Yeah. So if you look right here, here you go 3, 2, and 1. Here's 3, 2, and 1. So that's actually just going to cancel out. So technically, all you have to do is 7 times 6 times 5 times 4. So we're going to do 7 multiplied by 6 multiplied by 5 multiplied by 4. And you get 840. And that's it for that one. Any questions so far on that problem? All right. So up next, I'm going to show you how to do this problem by using the calculator. So if you do have the TI-83 or TI-84, you do want to take it out for that way you can practice on this. So I'll give you a minute for that way you can just take it out.
What are we doing?
Taking out your calculator.
Oh,
Are your rugs dirty in the restroom? So I can give them some.
sí.
Cool.
Creo que
All
sí.
right. So hopefully you should have the calculator out. So what I want you to do, so whatever your n is, you always enter your n in first. So you go 7, because n is 7. So then what you want to do, you look right here where it says math. You want to click the math button. And if you look at it, you want to go all the way over where it says PRB.
Wait,
you
how
go-
do I get there?
So you hit the math button.
Okay. And
And
then,
then you go all the way over where it says PRB. So if you look where it says PRB, you see how it says NPR?
yeah.
NPR is for permutation. So I want to select permutation. And then lastly, what you want to do, enter R. R is 4. Cool. And that's how you do it with the calculator.
Oh, it says air. Yeah, I don't know why it said air. Oh,
Does
I
it
was
say
supposed to put
7 NPR 4 like mine?
No, so I put 7 and then I go to math.
Yeah, so you put 7, then you go to math.
NPR or yeah, now it works.
All right. There is a shortcut for factorial. If you want to use the factorial button, Amanda, you go to math, you go to PRB, and if you look over here where it says number 4, it has factorial symbol. But you should just use the NPR because the NPR will be easier to use. All right. Cool. Any question in regard to how to use the permutation or anything like that? All right, cool.
For the test, do you want us to do it by hand like that, or can we just use a calculator?
For this one, I really don't care. You can either do it by hand or you could do it on the calculator. It's the same for me.
Okay.
All right, so let's do this next problem. So for this one, it said, in a race in which 6 automobiles are entered and there are no tie, in how many ways can the first 4 finish come in? So I'm gonna kind of show you why this is a permutation. So for this one, you first have to look at n. So for this one, do we have n distinct objects? Because for this one, how many people are racing?
6.
6. Can we kind of assume that all 6 of them are different?
Yeah.
Yeah. So for this one, we have 6 distinct objects. So for this one, can we have any repetition? Like whoever come in first place, can they also come in like third place? Or is it like if you're in first place, pretty much you're in first place and then I can select you?
Is it just one and then done?
Yeah, pretty much it's one and done because once you get a place, pretty much that's your place. You can't really get anything after that. So for this one, there is no repetition. And what about for this one? Does it matter who come in first, second, third, or fourth? Like, does it make a difference, or would it make a difference? Like, if you come in first place, second place, third place? Like, it should make a difference because if you come in first place, you're in first place. If you come in like sixth place, then you don't even like probably qualify. So it does make a difference. So for this one, order matter. So that way, this is a permutation. So for this one, which places do we care about?
First, second, and third.
Well,
Fourth.
let me see one of that.
First four.
Yeah, first 4. So that means R in this case is equal to 4.
Can we just do NPR for that?
Yeah, we'll do NPR first. So we do N, we do math, we do PRB, we do NPR, and then you do 4, and you go 360. So we'll say 6P4 is equal to 360. Cool. And we're done for that problem. Any question in regards to that problem?
So why do we do 7? Oh wait, never mind. 6 NP4 and that's it. Okay.
Yeah. All right. There,
So we can
like,
just
if you look at this problem, you could also just do this by kind of like logically thinking about it.
why do we write it as 6P4 instead of 6 NPR4?
Oh, because usually, well, because in the calculator it has NPR, but the N is 6 and R is 4. So I'm just replacing that.
Okay.
Also, like for this one, you could do it logically. Because if you go like, how many options do we have to choose for a first place? There's 6 people that could come in first place. Once you get 6 people to come in first place, now there's only 5 people that could come in second place. Now there's only 4 people that could come in third place, and there's only 4 people. Well, sorry, there's only 3 people that could come in fourth place. So if you do 6 times 5 times 4 times 3, it gives you 360. So that's what the permutation rule is doing, is saying these are the different amount of sequence that we could get for this certain outcome. All right. Any question for that last round? Cool. All right, so let's do the next one. So the next one says a corporation has 10 members on its board of director. In how many ways can it elect a president, vice president, secretary, and treasurer? All right. So for this one, how many options do we have to choose from?
10.
Yeah, cool. 10. So that means N is equal to 10. So is it safe to assume that these 10 people are all different? Like, can we assume that the 10 represent 10 different people, not like we have multiple people?
Yeah, we can assume that.
Cool. So that means we have N distinct object and there is no repetition. For this one, does it matter who I give the president, vice president, secretary, or treasurer job?
Yes, it does.
It does matter. So in this case, order matter. So in this case, since order matter, there is no repetition, and we have N distinct objects, this is going to be considered a permutation. All right. So for this one, of the 10 people, how many job positions do we have?
4.
4. So that means R is equal to 4. Any question why R is equal to 4?
Because we have the president, vice president, secretary, and treasurer.
Correct. All right, so let me go ahead and do that. So first enter the 10, then go to math, go to PRB, go to NPR, and then just enter 4, press enter. And you get 5,040. All right, and that's it for that one. Any question for that last problem?
That's like the final answer.
Yeah, this is the final answer.
Okay.
Because it is asking us how many ways can we elect a president. So this is how many ways we can elect a president, vice president, secretary, and a treasurer.
Okay.
All right. Everybody good for permutation. All right, so let's go down. Up next, we're gonna do combination. So for combination, the first two conditions are the same for permutation. So it has to have n object are distinct. Repetition of the object is not allowed. But in this one, order is not important. So say if I have like the order of A, B, C, and the order of C, B, A, in this case, it will treat them as the same because in this case scenario, we don't care about the order. So we don't care if it's A, B, C or C, B, A. All we care about is that they're selecting A, B, C. So for this one, if it says order doesn't matter or the way the scenario is kind of laid out, if they kind of say that the order doesn't really matter, then you want to use a combination rule. And for combination rule, you want to use NCR. Any questions so far for that? All right, so let's do some of these problems. So for this one, says a election ballot asks voter to select 3 city commissioner from a group of 6 candidates. In how many ways can this be done? All right, so how many people do we have to select from?
We have 6.
You have 6, so we'll put 6 right here.
All right.
How many people are we selecting?
3.
3. So that means R is equal to 3, correct? So for this one, does it matter who they pick first, second, or third, or are they all gonna still get the same thing?
We're all gonna do the same thing, right?
Yeah, they're all gonna get the same thing because all of them are gonna be city commissioner. Oops, don't want to do that. Okay, it doesn't matter who I pick first, second, or third, because at the end of the day, they're all gonna get hired or they're all gonna get elected to be the city commissioner. So it doesn't really matter who go first, second, or third. So that's why this is combination. Oops. Cool. So for this one, we're gonna do 6C3 because the C just stands for combination. So we'll say 6 math PRB. We'll do NCR, and then you put 3, and you get 20. And you're all done for that one. So that means there's 20 different ways that I could select 3 city commissioner if the order doesn't matter.
Okay.
All right. Any question in regard to that problem?
Mm-mm.
So for this problem that we did right here, say if we were to do a permutation, do you think the permutation would have given us more outcomes or would have said we have less outcome?
Would you get more?
Well, why would you think it would give us more? Like you are right, so.
Because with the permutation, don't you have to do 6 times 5 times 4 times 3 itself?
Technically, mathematically wise, that will be correct. But like the 20 telling us if the order doesn't matter, correct? But isn't with permutation is order does matter. So if order does matter, wouldn't that mean that we will have more than 20? Because now if order does matter, like when we have A, B, C, and C, B, A, instead of looking at this as one outcome, in permutation, you can say we have two outcomes. So if you actually do permutation for this one, you should get a bigger number, or you should get more results. If for permutation, it's saying the order does matter. So if order does matter, that means you're gonna have more outcomes. All right. So let's do the second one. So it says, suppose you find 7 articles related to the topic of your research paper. In how many ways can you choose 5 articles to read? So for this one, how many articles do we have to choose from?
7.
7. Can we assume that these 7 articles are all different from each other? Or are like all of these articles the same, or are they different? Well, for this one, we should just assume all 7 articles are different, because I'm pretty sure they're not going to be selecting 7 of the same article, or like 2 of the 7 are the same article. So we're going to assume all of them are different.
Okay.
For this one, like once they read an article, are they going to go back and read the same article, or are they going to go and read a different article?
So we're just gonna assume that they're gonna read another one.
They're going to read another article. So in this case scenario, we were going to assume this is done without replacement, because once they select the article and read it, they're not going to go and say like, I'm going to go ahead and read that article again. So we're going to say R is equal to 5. Cool. And we're saying R is equal to 5 because they tell us they're going to choose 5 articles. For this one, does it matter the order that they choose the article?
No.
No, because pretty much it doesn't matter which one they read first, second, third, fourth, or fifth, because at the end of the day, they're going to read all 7. So for this one, we're going to say 7, C, 5. So we're going to say
Only one.
7. We'll do math, PRB, NCR, and we'll say 5. And you get 21. So there are 21 different ways that they could select 5 articles out of the 7 articles. And that'll be it for the last problem.
I have a quick question. For like a quiz or a test, are you gonna like have these mixed up together? Like for example, permutation and combination, or are they just gonna be like, we will know which one's which?
Well, if you mean like, am I going to tell you, are they a permutation or combination? No, like that's going to be up to you to decide. So like, I'll you give you a problem like this one, and you, based off of the reading, you have to go like, okay, does the order matter or does the order not matter? If the order matter, then you know permutation. If the order doesn't matter, then you know the combination.
For sure. Gotcha. Thank you.
Cool. All right, so I want you to do the last one. So I just want you to get what the N is, what the R is, and find me how many different ways can they select 3 people to refill this cooler. So take a minute and try doing this one right now.
Gotcha.
No. I got 286.
286. Well,
I got 680.
I got 680.
cool. All right, let's check that. So for this one, what do we get for n?
17.
Cool, perfect.
Oh, I wrote it in wrong. Yeah, that's why.
What do we
I
get, r?
3.
3. And for this one, does order matter?
No. They just forget the cooler.
Exactly. Cool. So this combination. So we want to do 17 C3.
Yeah,
And what did we get?
680.
680.
Cool.
Yeah, I wrote 13 instead of 17. That's why I got it wrong.
Okay. Yeah, just be careful with that. All right, cool. And that's it for combination. Any question in regard to combination?